So what is the perimeter of the paperboard that remains after the semicircle is removed? So they're cutting out the semicircle. We're supposed to find the lengths of a string, the length of a string that would go all the way around this perimeter that I just drew. So a couple of the parts are easy. 33 inches here plus 24 inches. And then this is a rectangle originally, so that's another 33 inches up here. So right now the perimeter, oops, trying to move it, won't let me. Okay, let's do it that way. Perimeter is going to be 33 inches plus 24 inches plus another 33 inches. Now we need that curve. And that's kind of the tricky part. What do the instructions say about pi? Yep, they say to use 3.14 for pi. So here's what we're going to do for the curve part. The circumference of a circle is the length of a string that would take to go all the way around the circle. And this is just half a circle. It's a semicircle, right? So I'm going to use 0.5 and multiply it by the circumference. Circumference is 2 times pi times r. What did they say for the radius of the circle? Okay, they don't directly give us the radius. We need to know it's 2 times pi times r, so we're missing a radius right here. To calculate that, though, we can use the fact that this on the drawing would be the radius. That's half of the height of this rectangle, so that's 12 for the radius. Okay, so down here, we need to multiply by 12. Okay, and then this is the hardest part, so let me just recap where this came from. This is the circumference, this is the length around an entire circle. But it's a semicircle, so we got to multiply by 0.5. Got to multiply by a half, because we're only doing half a circle. Okay, so let's do 33 plus 24 plus 13. Sorry, plus another 33, not 13. So we got 90 so far when we add the Plano numbers. Let's do all that multiplication all at once in our calculator. So it's 37.68. Let me just double check. Yeah. And then if we add those together, got 127 and 68 hundredths. So that's the length of the string. And that's feet, not feet squared, not feet cubed, because it's one dimensional, right? It's string, so it's either left, if you were to take that string and stretch it out, the length of that string you can either go left or right when making that calculation. One direction. Two-dimensional area would be feet squared. Two-dimensional areas when you can go up, down, left or right when you're calculating the space. Okay.